Right. So if you remember the last time when we met, we talked about our solar system, and I just scanned through my presentation, just telling the basic properties that we have in different planets. And the planets are basically divided into different categories. Basically, there are two categories: terrestrial planets and Jovian planets. And terrestrial planets are the first four planets in our solar system, that is Venus, Mars, Earth, and Mercury. So those are the four planets, and so there are very specific things that are unique to some of these planets, and we have talked about those as well. So if I just share with you the presentation that we completed last time, let me just give me a moment to share this. This is not actually what we have talked, so let me. So we were basically talking about the solar system. So I hope you can see my presentation now about the solar system. This is what we talked last time. So we basically defined how definitions, how we define a planet and how we define a dwarf planet. And then we talked about the asteroid belt, which is located between Mars and Jupiter. And then we talked briefly about the comets and Kuiper belts. And then tidal forces we actually have talked even before. And then I showed you this diagram how the planets are divided into different categories. And then we talked about the scales of the planets compared to the sun and different properties of the planets. And then we have talked about this nebula hypothesis, which is the idea that we have right now about the birth of the solar system. And this basically explain like different steps. I guess you can just read through and you will understand this, right? And then there are evidences to show that our solar system has created from a nebula. And then I have this problem actually posted for you, so try to find the answer for this one. We may discuss it probably towards the at the end. And then we talked about terrestrial planets, different properties of terrestrial planets. And then we specifically talked about Mercury because it has this orbit that goes into the reverse direction. Sorry, not the Mercury, actually Venus has the retrograde direction. And then Mercury, in fact, has this different path on the sun, which we actually talked last time that this is due to an effect coming from the general relativity. And then for the Venus has different kind of characteristics, and one of the main features is that it's retrograde rotation, which means it rotates its with respect to its own axis towards the uh, uh, okay, so so there is a question. Let me, okay, so just post the questions. I will take those at the end about this assignment. Yes, I will talk about that in a minute. And so then we talked about different properties of our own Earth and the structure of the Earth. And then we talked about these Van Allen belts. And under that, I have also talked about how these northern and southern lights or the auroras occur due to the charged particles interact with, basically due to the charged particles interact with our uh, magnetic field, and these charged particles are coming from due to the solar winds created by sun. And Then we have some details about Mars exploration, and then there are actually some videos that I have put here, so I will try to give you links for that. And then we briefly talked about the Jovian planets like this, and then different missions that we had for giant planets. And then I actually, at the end of this, since I did not talk much about the Jovian planets, I would like you to explore details about those because it is not a hard one to do. You can check the assignment that I had posted. So what you can do is have your assignment done. The question is actually, let me see. Question is actually write a two-page summary about Jovian planets. It means there are different characteristics and the features, or some of you can just, I mean, it depends on you. You can structure it any way as you like. So what I am going to do at the end is, so once all of you submitted it, I may give you a note about the Jovian planets, but I will make the note based on what you have given to me, right? So that's how it should work. So this is like your part of the lecture, right? Otherwise, I am just teaching from this side, and even I haven't seen you, and you are just listening, right? So this will be your part. So make sure that you submit it. And for those who have issues, like that, I have a message from one of you telling that you have issues in uploading it to the Google Classroom. Then please email to me for this particular address. So let me. Now for this one, actually, you can write a two-page summary, but it doesn't mean that every one of you need to write just only words throughout 2 pages, right? So be a little creative, and you can do it in whatever way that you like. And at the end, when I make the note, I will probably take all of your note and see which way that probably would be better. What are the information that I can take from you? So this will be then easier for your exams as well, because I will be focusing on what you know from your notes, right? I mean, assuming that you will write very good summaries. So this can be flow charts. You can include charts and then measures if you like. But remember that anything that you include should have a meaning for that, right? It's okay that you use less amount of word, but at the same time, what that means is your picture should tell a lot of information, and you have to explain the picture, right? And you can like use like charts, like flow charts, those kind of things, whatever you like. So there is no limit or no restrictions for that, right? Only thing is make sure that you limit it to 2 pages, maybe maximum maybe 3 pages, and your font size and everything I have given in the assignment. So use those, and those who cannot upload it to the Google Classroom, then you can send it to me to this email. And please, if you can upload it, don't do that. This is only for few students. If you get any kind of problem in uploading, then you can send it to me, right? And the next thing is that, right, so that's it for this particular thing. And there is one topic that actually I would like to talk under the solar system, which is about stars. I mean, not stars, which is about our own sun. And because the sun is also one of the stars that uh, we have, because we will be basically talking about stars throughout, starting from today for the I mean good amount of lectures, right? And because of that, I will be actually not talking about our own sun right now. So I will get back to that particular section, which is a very small section in terms of I mean, in terms of maybe just a half an hour thing in one day. I will talk about sun after we talk about these stars. right? Because once you get the idea about all the properties of stars in general, it will be easier to talk about the sun, because sun is just one of those stars, but it is specific to us for a reason, because it is close to us and all the power and the energy is coming to us from the sun. So we will talk about that later, right? So that's about the assignment and everything. And let me uh, just go back to one thing here, that is about, remember that we talked about telescopes uh, last time, and there was a question from one student how to choose a telescope and these kind of things. So I just made two slides about, just to give you an idea how to like select a telescope. And so I am under the assumption that probably all of you may have a good idea now, since we have done with that section about telescopes. But let me just share this two slides with you so that you probably get a better idea. I mean, just an explanation, I mean, just more elaborative way of telling it. So let me stop sharing this one and then go back to that particular presentation. It should be right here. So while I am looking for it, if any of you have any questions to ask, please feel free to ask at any time as usual. This should be stop. Right, so it's right here. Right, so let me share this with you. Right, so we had a section that we finished about electromagnetic spectrum and telescope, and I would assume that you can see my presentation for that particular section. And remember, we talked about telescope, electromagnetic spectrum, and different types of telescopes, that like refracting, reflecting, this type of telescope, and there is a type called Dobsonian telescope. I mean, these are basically different like variations of either refracting or reflecting telescopes. And then there is another type called Cassegrain telescope that uses a different technology. And then we talked about very large telescopes that professional astronomers use around the world, and also for large sky surveys. And this part is in fact very important, the light gathering ability of a telescope, how to calculate the light gathering ability. And then what is the advantage of having small telescopes and the larger telescopes, like telescope sizes. And then we talked about the resolving power of the telescope. And this is probably, if you haven't seen it, these are two telescopes in the same facility in Kitwick National Laboratory, which I have personally used. The one in the left-hand side is a very large 4-meter telescope uh, from the outside view. And the one in the right hand side is a 0.9-meter telescope. And I guess I have talked to you about what this uh, term means actually for astronomers. When you say 4-meter, that means the diameter of the primary mirror, right? 0.9-meter is the diameter of the primary mirror again, right? Then we talked about resolving power, right? So this is what I just added according to your request. Now, choosing a telescope, uh, is actually not, I would say, not the easiest decision to make, because there are some factors that determine which telescope is right for you depending on your preferences and needs, right? Now, some of the things actually we normally consider to buy a telescope is the one is that will you be setting up the telescope in one place and leaving it there, right? I mean, I am just talking in general, not I think that you may be asking about a smaller telescope, right? But what I am talking about here is in general, about any telescope, like including large telescope. One thing that we need to consider is whether we are going to setting up a telescope on a one place and then leave it there, right? Or whether we want to have a portable telescope, which means you can take here and there. Right now, for the general use, I assume that most of you are actually asking about these portable telescopes, right? And then the next thing is, if you want a portable telescope, then how portable should it be in terms of the size and weight? Now, you probably would be wondering why I am talking about the size and the weight of a telescope without talking about its optical quality and everything. But this is actually one factor that affects in the practical situation, because if you, for example, if you need to do good observations in professional grade observations, you need to have a good tripod which is stable and a large mirror in the telescope, so which will give you a good image quality and you can see a lot of things. But at the same time, when you have this kind of telescope, it becomes very heavy, and sometimes when you go to larger telescopes, even then you can actually uh, remove parts, and you cannot remove parts and take it to another place, right? So these are like pros and cons of having large telescopes. Now, the other thing is that you want to consider is that do you want to observe the sky with your eyes only, or do you want to take photographs? So what that means is there are certain observers that are interested in taking these beautiful pictures of the sky, like of the Milky Way galaxy, of the planets, and those kind of stuff, right? Now, uh, if this is the case, then there are some specific telescopes that are made for that particular purpose, right? But if you are just using use this to sky with your eyes, so what that means is actually you are not using your just only eyes, but you buy a telescope and you keep your eye on the eyepiece and look at the sky through your eyes and through the telescope. Uh, but if you need to do photography, instead of looking at eyes, what you are doing is you set up a camera for the place where you have the eyepiece in the telescope, right? That's another thing. Then uh, the next question is actually you have to ask what type of objects that you will be observed. Are you interested in primarily in comets, planets, star clusters, or galaxies, or do you want to observe all kinds of celestial sights? So this is another thing, right? What kind of objects that you are looking at, right? This is uh, basically the maybe the most important thing, because if you are looking at comets, and maybe you are, if you are looking at only planets, maybe a small telescope will do the work. I mean, we'll just be able to see somewhat some of these planets. You can see some of them are even from the naked eye. Even for example, if you go outside, I guess the Mars should be visible in these days, even for the naked eye. But you will get a more clear, magnified version from a telescope. But if you want to look at galaxies, so these are faraway objects, right? And including planets and galaxies and all these things, then you may need a better quality telescope, right? So you can see that it's a hard question to answer when somebody asks from you what kind of telescope is better. It basically depends on what you need to look at and how portable that you need for this particular telescope, and do you want to make photograph, those kind of things, right? Right. Now, those are like, in general, those are the things that you want to look at. And here are some points apart from that in the technical side, what you need to consider when you are buying a telescope. So that is, the one thing is the aperture or the main mirror of the lens. So this is probably the first thing that you need to look at, because the larger the mirror, it's it is better in collecting light photon from the sky so that you can see fainter objects. That's kind of the rule of thumb or the basic technology. And so which means basically you can look at more fainter objects, right? Now this is one important thing. And the other thing is the telescopes of a given aperture that use lenses. Uh, I mean, if you look at the prices, the telescopes for a given aperture that use lenses, these are refractor telescopes, by the way. So they are typically more expensive than the use of these mirrors in the reflector telescopes, right? And you can see that for the money that you spend, it is always I would say that if you are going to use it for just casual observations, it is always cheaper to go for a reflector telescope. But I have seen that most of you are trying to get these refractor telescopes, which are actually higher in price, and you have to pay for the same aperture sizes. You have to pay more for the lenses, because you know these lenses you have to make two curves in the two sides, so it is expensive, not like mirrors. Uh, and then one thing that you need to make sure is that the magnification is not one of the criteria on which to base your choice of a telescope, which means you don't choose a telescope based on your magnification of the telescope, right? Because when you go to a website or somewhere to a shop in anywhere around the world, any these salespersons, they try to sell telescopes based on the magnification power, but that should not be a factor actually to buy a telescope. Why is that? The magnification is just that once you collected all these photons, you magnify it through another lens inside the telescope. But what happens? I mean, it doesn't collect more light, right? You just have one image and you magnify it. Then what happens? The quality is actually degrading. So if you have like unusually high magnification, you will in fact not see anything, just a blurred image, right? So that you need to be careful with that. And the other thing is the mount of the telescope. So it's very critical, because the telescopes comes in different types of mounts, right? Some comes in something called equatorial mount, and there is something called altitude azimuth mount. And these more advanced mounts like equatorial mounts are actually very good in terms of tracking objects and everything, but at the same time they are hard to set up. So because of that, you need to think that if you just use for like casual observing with kids and someone who is like just interested in only about astronomy, then maybe it's better idea to go for these basic telescopes with simple mounts. And also if the mount is heavy, that's also useful, because then the telescope will be bit sturdy. But at the same time, you know this it will get heavy as well. So there are a lot of things that you can see, you probably need to think about before you buy a telescope. And it's basically like, I can summarize this into three, I mean one or two things at the end: how much money that you have, what you need to do with the telescope, those kind of things, right? And then it's easy to like select the one, right? Especially, I mean, in Sri Lanka, actually, there are no like much selections for telescope. There are only few places you can buy it, but if you go for worldwide, there are a number of different types of telescopes, so that you have to take all these factors into account when you buy a telescope. Now, I can just give you one good example that I just show. Let me now. So actually, that's what I want to explain you about buying a telescope, because one of you actually asked specifically about that. So I added two extra slides here, and I will be posting this too. Your Google Classroom will soon as well, right? Uh, uh, while I am taking out my next presentation, and there is a link that I want to show about how this size of the telescope is affecting what you are looking at. Uh, you can, if you have any questions, you can ask while I am just going to my next section. To show you something interesting about. All right. Oh, by the way, that I forget to tell you about that for this assignment. You can use this particular chapter in the book that I have the posted the link. The good thing about this book is it is very there is an app that you can directly use in a smartphone if you don't have a computer, and it is nicely organized into different chapters, which make it easier to look at it even from a smartphone, right? So make sure that you get that chance and use that chapter itself and make your summary. That will be a lot easier, but you are free if you need to look at other sources, you can do that as well. It's okay. Right, so let me share this particular document with you now. So I'm just sharing a link with you. I hope now you can see it. This is actually an article just published yesterday in Sky and Telescope magazine. And this is just basically briefing the comets that you can watch in 2020, right? But see the topic here. If you were on an 8-inch or larger telescope, you might see more than dozen new returning comets this year. So there is a condition for to look at these comets, right? Now you can't just buy a telescope and then look. Then don't think that you will be able to observe all the comets that will come in each and every year, because there are comets that will come in I mean, will be observable from Earth, but you need to have an 8-inch or larger telescope. What this means is actually the primary mirror that you have in your telescope should be have a diameter of 8 inches or more than that, right? You may convert this into centimeters to look at what value that you have is for the 8-inch. But you have to have this kind of telescope, right, to look at these comets. If you have it, then you can go through this article and locate and try to see some of these comets. But the thing is that you can see that it depends on what size of the telescope that you have, right? And this is why most of the time the general public get these things wrong, because you cannot see all the objects by just having a small telescope, right? So it depends on what you need to look at, right? So that is one thing that I just want to share as an example. Now let me stop there, and I can also share that article if anybody is interested. Just these are the comments that will come out in this year. Right. Now let me go back to my main presentation. Now from today on, I am going to talk about stars. Right. So we have been talking about basically the ancient astronomy and different coordinate systems, and then we talked about electromagnetic spectrum, how it is used to build up different telescopes and how we do observing, and then different telescope types, how to select a telescope. Those are the things that we talked, and then we move into talk about the solar system, and we basically discuss different properties of different planets and those kind of things, right? Right now, in the next step, I will be going into talk about stars, right? Because that is the next scale. Now, this is like a tour. You can see that, right? We initially started from the technologies and different things that we need to do the observations and the coordinate systems, and then we move on to talk about our own solar system. Now we are going to go a little bit beyond, which means we are going to start talking about stars, right? Which is probably like the heart of this course. Let me share my new presentation about stars. It's taking a little bit time. Right, so I have just shared my presentation with the first slide with the topic called stars. So make sure that you can see my screen. So I hope that all of you can see the screen. Right. So basically the stars is what you can see most of the time when you go up and look at the sky at night, right? Now, anybody have any idea, like on average, how many stars you can see up in the sky on a dark, clear night? Do we have a number for that? Or we don't have? Basically, actually, on average, we normally used to tell that we can look at around like maybe 2,000 to 3,000, around 3,000 stars for one night on a very clear night in a dark, from a dark place. And so that's kind of the assumption. And I know this is true for a reason, that if you go for a very dark site without any lights, and if you can see the full dome, which means if you can see both, if you can see the horizon very clearly, then actually you should be able to see lots of stars, large number of stars, around 2 to 3,000 in each day. But unfortunately, nowadays that you have a lot of light pollution in very close to city areas, that it's hard to see large number of stars because the light is dominating. Now, in this particular chapter, we will start to talk about overall properties of the stars, and then the way in which the stars form, evolve, and maybe die. Right? So this is what we will be talking, but during this journey, we will meet a lot of things. Now, in the first chapter, we will just talk about different properties of the stars, how we can measure those, and why they are important when we are talking about the stars, those kind of things. But after that, we will move on to discuss about the evolution of stars. That is, how stars form and how they evolve with time, and what are the conditions that they have, and under the different conditions, how what will their fate at the end, right? Now, during this journey, you will probably learn most of the important things about stars and whereas in the field of astronomy, because the stars are like uh, one of the major fields, like studying stars in astronomy. Right. Now, if you look at the shape of the stars, actually they are kind of essentially large sphere of gas that emit light. So that's what we can tell in most simple way. We talk about it. Now, we think that the sun is a very special star normally because we get sunlight, but The reality is actually the sun is just a fairly ordinary star, right? Uh, but what has happened is it appears very bright for us because it is very close for us compared to other stars, right? And I will show you examples how the brightness will change if you remove the star, our own sun from this position, and if we keep the same sun in similar distances like other stars, right? Now, if I consider our galaxy, we know that literally billions of stars uh, we have in our galaxy, right, and even beyond. Now there is a one survey which we call it as Gaia, GAIA, that is specifically sent out to the space to measure the distances to these stars. And this is actually done by using a method called parallax method that we will talk maybe today or if not in the next day. And the satellite actually measured the distances to all these stars. And I guess there are around maybe few billions of stars that it has measured the distances to all these stars very accurately. And also, when we talk about stars, so there is an incredible variety in the types of the stars that are seen. So they are starting ranging from stable stars like our sun to exploding stars, white dwarfs, and black holes. Like basically, these white dwarfs and black holes, so they comes into play during the last period of a lifetime of a star, depending on their masses. Right. So this is how the sky looks like tonight. If you look at just a picture of like large number of stars, and you can see different colors that you have in this picture for different stars. Some of them are like greenish white color, and some of them are yellow color or reddish color. So this depends on, this is because on average when you look at the sky, you are basically looking at a statistical sample, which means there are all kinds of stars on the sky, right? Some of them are maybe at their middle of the lifetime. Because of that, they emit different kinds of gases and maybe radiation, so that they will have a different color. And some of them may be towards the end of their lifetime. And when you have low mass stars towards the end of their lifetime, they have become, or they will become white dwarfs, so that you will have a different color. So likewise, this is why you have we seems to have these stars are very colorful when you look at the sky, right? Now, when we consider about the properties of the stars, basically we will be actually talking about uh, these 7 properties in this particular lecture, right? So that will be the brightness of the star, the color of a star, and distance to a particular star, and how to measure distances, and how to find the size of a star, and the temperature of a star, age of a star, life expectancy. So these are the basic properties that I would like to talk in this class. So once again, the brightness means, you can see the brightness, you know the idea, right? Color means actually there is a term called color of a star, which is actually measured, and we can measure it. And we will talk about that actually under each of these sections. And there are methods that astronomers have developed to measure the distances to these stars. And one of those methods is, in fact, is that parallax method. And this is the method that this latest satellite called Gaia has used to measure the distances to the stars inside the Milky Way, and then the size of the star. So you basically can measure the size, like how large is the star, and the temperature of that. And temperature again also will depend on where it is located. I mean, at which particular time is in that particular star, right? So then the temperature will depend on that. And then the age of the star we can predict, and also the life expectancy, like how long will this particular star live before it gets explodes or destroyed, like that, right? So how we are going to discuss these things is that we will discuss how astronomers go about measuring many of these properties. So we need to know that. So the first step or the first chapter will be devoted to discuss how these measurements are taken, or how astronomers make measurements of these properties, like the light, color, brightness, distance, those kind of things. And also you will see that most of these properties that you see is actually correlated with one another, which means temperature will affect the brightness, like that. And the brightness is also affecting where it is located, or how far is it from us, those kind of things. So these are actually interconnected to each other. Now, our goal is actually in this lecture is, for this lesson, is to use these properties that we are going to learn to develop and understand the many different stars that we see. So that's the idea. So we are going to learn these properties, and then we will apply those to understand the properties of different types of stars. So that will be the aim for this particular lesson. Right. Now the first one is actually the brightness of the star. So let me see what is the time now. Right. So I guess we have time to continue. And the brightness of the star probably is the most obvious thing that you will see up in the sky. Uh, because you can actually differentiate the brightness between stars. Now, the good way to do that is go outside today and look at probably the Orion constellation. And when you look at the constellation, you can, if you find the constellation, you can directly see that from your eyes that these stars that you have, even in the single constellation, clearly vary in terms of brightness. Now, for example, this star called Betelgeuse is actually one of the brightest that you would see on the uh, constellation Orion. Uh, and it's very clearly visible, and even for the to locate the Orion constellation, it is easy to locate this bright star Betelgeuse, and then you can make the connections to other stars to find this constellation, right? Now I'm not going to show it today, but I have actually shown you through these softwares that how to look at, or how to figure out the location of these constellations and how to look at it, right? So try to do it yourself, and then you will see that clearly there are differences in brightness. Now, for example, the sun is unusually bright for us. So it's really, really bright. Right? And this Betelgeuse is very bright. So they are, this brightness comes for different reasons. Either they are actually bright, or sometimes maybe they are very close to us. Now, for the case of the sun, it is bright because it is very close to us, right? And for the Betelgeuse, actually, it is bright because it's kind of in a stage that it has these more reactions, and because of that, it looks bright, even though it is far away from us. So we will learn about those things. Now, the brightness. So there should be a way to measure this brightness now, right? Now, one way actually is in 150 BC, one of these astronomers called Hipparchus, he devised a scale for describing this quantity which we called as the apparent brightness of a star. So that means how bright a particular star when you look from your eyes, right? You can tell that, can do a comparison, like some of these stars are bright from to the eyes and some of them are not that much bright. But then how to quantify this? So uh, this is what Hipparchus did at that time. And this the magnitude that you see from your directly from your eyes, or without doing any modifications, the brightness of the star that you see is what we called as the apparent magnitude. Right? Now, this is what Hipparchus did. Actually, he assigned number one for the magnitude for the brightest star visible in the night sky. So its apparent magnitude is one, and then he looked at the faintest star that he can look at, and then he gave an apparent magnitude of 6 for that particular star. Right? Now, the stars between that range, so they are given a magnitude value between 1 and 6. So that's what Hipparchus actually did at his time. And now the interesting thing here is in this ranking system, the faintest star is assigned the largest apparent magnitude. Right? So this is still valid, and this is the scale that we are still using. Normally in astronomy or measuring the brightness, the number, when the number is higher, that means that particular object is actually fainter. If the number is smaller and if it is even minus, that means those kind of stars. So if, once again, if the number is higher, they become actually fainter. If the number is lower, then they become brighter, right? So that's how these stars are actually categorized. So in terms of magnitude. So make sure that you all the scales now normally in day-to-day life that you see is completely different what we are talking here, right? This magnitude scale to measure the brightness for the stars. Once again, the lower the number, brighter the star, higher the number, the fainter the star. Right? So that's how it works. Right? And right. And the modern apparent now this was what is used at that time. Now we have a modern magnitude scale for the apparent magnitudes. This is because instead of simply ranking the star's brightness by eye, the accurate measurements of brightnesses can be made using CCDs, especially in these days. CCDs means charge coupled devices, and there are CCD cameras that astronomers use by coupling the camera with the telescope so that you can take the image and then you can measure the brightness of a star. Right? This is how modern astronomy works. Now, once you measure the brightness in that way, this is the scale that we are using now. That is actually the star of apparent magnitude 1 is now defined to be exactly 100 times brighter. Right? If you have a star with the apparent magnitude of 1, so that will be 100 times brighter than the 6th magnitude star. Still the numbers are the same, but this is the definition. If you have an apparent magnitude of 1 star and apparent magnitude of 6 star, this star with apparent magnitude 1 will be 100 times brighter compared to this star with the apparent magnitude 6, right? You can see that the difference of the magnitude is 5 and the brightness has increased 100 times for that difference. So that's what you need to note down here. And in fact, any two stars that are that differ in brightness by a factor of 100 are different by exactly 5 magnitudes, right? So that's what you need to remember here, right? There are two stars that has the brightness differs by 100 times. Then what that means for the magnitude scale is one will be, sorry, the difference of the magnitude will be 5 magnitudes, right? Now, this scale can be applied to stars that are much fainter than those in the night sky, and also to other objects such as the sun, moon, planets, and even galaxies. So, this same scale actually can be applied for different other uh, objects like galaxies and planets as well. The idea is that uh, it is possible to apply this to much fainter objects than what you see up in the night sky under this particular method, right? So that is the advantage. Right, so here are some actual examples of apparent magnitudes for different stars that we see up in the sky. Now, most stars visible to the naked eye still have the modern apparent magnitude between 1 and 6, right? Which means all the stars that we see from our naked eye under really good condition will have a maximum value of 6. Normally, this number 6 in the magnitude scale we used to tell that as the naked eye astronomy limit, which means if you have a faint object which we have, which has the apparent magnitude value greater than 6, which means, for example, 7 or 8. So that number itself tells you that you cannot see this particular object from your naked eyes and you have to use a telescope. Right? That's the idea. Now you know that the brightest star in the night sky is brighter than this, right? Because magnitude, when you say magnitude scale 1, it can also go beyond that from the negative side. It can be minus 1.5 like that, right? Now, for example, Sirius. Sirius is one of the stars that you can see up in the sky, has an apparent magnitude of minus 1.5, right? Now, Sun has an unusual apparent magnitude, which is an apparent magnitude of minus 26.7, right? Now, remember that when we go to more negative values, that means it means that it is even more brighter, right? So, Sun is probably the brightest one. Now, we may meet in our we may meet regularly, and as I told you, from the naked eye, you can go up to the magnitude of 6, which means you can see fainter objects up to the magnitude value of 6 from your naked eye. But if you have a binocular, then it is possible to see stars as faint as apparent magnitude of plus 10. So from a good binocular, you can go up to plus 10 in terms of the fainter limit for these telescopes. Now then, the deepest, right? Now if you just to give you an idea how deep or how far we are looking now, the deepest image of the sky that taken with the Hubble Space Telescope show stars and galaxies as faint as plus 30. And you can see how the technology has developed now. You can, from the Hubble Space Telescope, you can go and look at objects as faint as plus 30, right? So this should be very faint, and even you can't think about looking from a smaller telescope or from your naked eye. So that is magnitude, and this particular diagram basically explains you nicely how this magnitude scale works, and think that make sure that you let me show you. Make sure that you keep an eye on this magnitude limit. When you go down in the magnitude limits, things get fainter, right? It goes to plus value. You can see the Hubble scope limit for faint objects is right here. And then sun is right here up, the most brightest one. And between, and of course, the full moon is here as well, that is bright as well. And all the other planets, they are actually somewhat visible from the naked eye, but you can see that Venus is right here, Sirius is right here, all these stars that you can, it is visible. But when you go for this limit, for the plus 6, that is what we called as the naked eye limit, so that you cannot see anything beyond this particular point to your naked eye. So you need to have some kind of telescope. And binocular limit is right here. From good binoculars, you can go up to 10, magnitude scale up to 10, and then anything after that you cannot see even from a magnitude binocular, right? And you can see Pluto is very faint, it's plus 15.1. So this is why you cannot see these objects. And the large telescopes can go up to plus 21, and Hubble telescope can go to plus 30, right? So those are some information about these limits that you can observe, right? Right. So our next section will be about relate how the brightness is related to distances, right? So make sure that you understand everything up to here. So I'm going to just stop the lecture today after 1 hour, since I have to just